Hi there, this is Jacob Nash Algebra Lessons. This is Unit 7, Lesson 12, on how to solve logarithm and exponential equations. So we kind of already did something somewhat like this. These lessons might not seem to be in complete order, but this is just the way that I decided to do them. But this is kind of like, in some sense, like Lesson 9, but we're really expanding. And Lesson 9 didn't even have exponential things. But we also are reviewing some things from last unit that I briefly talked about with the Trash Can Academy lesson. Now we're actually using this in here. I maybe there is no reason to mention that in that unit with the radical functions, because it was more of an exponential thing anyways. But let's start out with logarithm. So there's two kinds that there can be. There can have one where there is log, and then one that has ln. And either way, you can't really do anything until you cancel them out, because just having those letters, log or ln, that's just not good, really. And we have the steps here, but you especially want to cancel them out for ln, and you can do that just by multiplying it by e, or if you see e, multiply it by ln. But let's start out with if there's logs, which is just a normal logarithm. What you can do is you use any rule, but typically the two ones you use are the a to the c power equals b, or a log b divided by log a. And this is reviewed in lessons 6, 7, or 6, 8. Wait, actually, 6 and 9, really. Those are two ones that I say things about that. And then if there's ln, well, we're not going to talk about that yet. So let's look at some. Oh wait, yeah, we are actually, because some of these have that. Okay, so if there's a ln, you have to isolate the ln so that it can be e'd, or you can pretty much put an e on there, and that will cancel out the ln's and the e's. So then you can solve as normal. But if both sides don't have a ln, then there will still be a e, because you have to multiply both sides of the equation by that. So we have 6 problems, and as you can see, I already have the answers there. That's just because these are easy to make a mistake on. Well, sometimes. But I just wanted to make sure that I was doing the right thing. These are just problems. And so we need to, using the rules that we learned in this lesson, we can see how to solve this. Okay, well, there are not specific names for them that I'm aware of, but you just kind of have to know by looking. And we can see, since we have the same base of 7, that what that means is that we can cancel out the log 7's and then make these equal to each other. So now we have 9x minus 4 equals x plus 20. Subtract the x on that from here. You get 8x minus 4 equals 20. Add 4 to both sides, and then you get 8x equals 24. Divide by 8, and you get x is 3. So I did that right, because that's what that thing says. I did think, though, I have 6 problems. I think 5 or 6 may have had an incorrect answer. We'll have to see. I can't remember. Maybe not. Okay, so for this one, let's see. We should get an answer of 49 over 4. That's not such a good answer, but you don't usually get very whole numbers. We're lucky we're even getting a fraction sometimes. Okay, for here, we have the same bases, so we can cancel out the log 3's. And that means that we need to multiply these, not add these, even though we have an addition sign here. The log that's right here, or not, sorry, number 8 here, that shows that that's what we need to do. Okay, so we need to multiply those instead, and that's equal to 69. Then we get 4x plus 20 equals 69. Subtract 20 on both sides, and you get 4x equals 49. Divide by 4, and yes, we do get 49 over 4. Okay, good. By the way, if you ever wondered how problems can get created, you just think of any answer you want the answer to be, then you can kind of just unsimplify it, and that's how you can get that, because I made most of these problems. I think all of them. I don't remember, but... Okay, here's one that doesn't look so good. Oh. What do we do here? So... Our solution is supposed to be x equals 173. Now here, I created this problem, so, but let me think. What's the best thing that we should do here? So we have a like, well, we do have a like basis here, the log 6's. Let me think. So then, because of that, let me find the rule here that says, wait, is there one that says that? I might have not even put one on here that, oh wait, these aren't the rules, those questions. I don't even know, oh, number 6. You see the log b's canceled. Okay, so that's what we can do. Something does seem a little bit off about it, but if you notice an error, please comment below. Sorry about that, but we're going to keep... Wait a second. Yeah, this problem may have an error in it, so I'm going to try to look at something here because I don't know what I might have gotten this from. I'm going to try to see if I can find the thing here. You might want to skip the video ahead, okay? Oh, wait a second. I know what it is. Okay, I know what it is. What was confusing me is this... Actually, these are not bases. I don't even know what was the problem here. Like, these are saying that's a value, not the base. And if there's no base, that really means there's bases of 10 there. So, I don't know if it wanted to do log 520 divided by log 6. Okay, that's not a very good number. That's not exactly solvable. I think the error was one thing is the basis, but also that I think the intention was for seeing that the answer is 173. The logs cancel, and somehow there's 3x plus 1 equals 520. Then you would get 3x equals 519, x equals 173. But that is incorrect, so sorry about that. I thought there was one of these that wasn't right, but I didn't even think it was that one. So, sorry, that's not a necessarily solvable one. Okay, so here, we can cancel out the logs because they have the same base. When there's no base there, there's really 10. But that doesn't matter because we can cancel out anyways. So we have x squared minus 464 equals 99. That's not so good. Well, the answer is something weird. Square root of 563. X squared equals 563. And you take square root, and you might think you get positive and negative square root. 563. That's the answer, but you can't have a negative logarithm, so we only have positive 563, or square root of 563. Can that be broken down further? Let's see. 563 divided by 4, not a whole number. 563 divided by 9, also not a whole number. 563 divided by 25, probably not. 563 divided by 49. 563 divided by 81. And I don't think... No, you cannot break that down further. That's not very good. Okay, so there you go. That is your answer. That's how you would solve that one. All right, let's look at this one. All right, the solution is supposed to be x equals 3. Here, well, this is kind of like the number 2. We can cancel out the these, and then we need to multiply these two things together. 8x. That's not going to be something that's x equals 3. I can already tell. Once again, I have to... See, I knew one of these might have been messed up, 5 or 6. I don't think 6 is messed up, it's 5. So, once again, sorry. I wish this screen recorder could pause, but let me see where this problem came from. From. Oh, I know what it is. I see the problem. This wasn't actually one I created. But the problem is that that's not supposed to be a plus. That's supposed to be a minus. Otherwise, you would get 8x cubed, and that would just not be a thing that there is. That would get that answer. So, sorry, that's supposed to be a minus. Still, these cancel out, but instead of multiplying these, you divide them. So you get 8x divided by x squared minus 1 equals 3. 3 is really over 1, so we can cross-multiply these. So then you get 3x squared minus 3 equals 8x. So, it looks like we're going to need to do factoring, so we need to make it set equal to 0. You just move this on the other side. Okay, we need to do bottoms-up factoring. Review. Okay. Then you would get 9. Alright, factoring, we can see that what two things multiplied equal -9, that add -8. I think it's going to be 1 and 9, and then 9 negative. That's what it is. Okay. So we have x minus 1, or sorry, plus 1, and then x minus 9. Those are our factors, still equal to 0, sorry. And then, because we did this bottom-up factoring, we need to remember to divide by 3. We get, okay, I'm going to need to move this over here. Alright, then we get x plus 1/3. Oh, working offline, I don't care. Dumb thing. OneNote's really dumb, so sorry about that. Minus 3 equals 0. Then we figure out they would be -1/3 and 3. But we only see 3 here. Why? Because -1/3 is extraneous. They could have put that on there, but it's really only 3 is the valid solution. That's what that is. Okay. Now we have a ln1. This is the only ln1. Remember, I said you need to isolate the ln and then multiply it by e. Alright. Oh. Well, we have 2 ln's, and we need to isolate them both. But that would not give you a value of 42. You can tell. But So this was also an incorrect one. I didn't mean to do that. Okay, so we're not going to get 42, but this still is solvable. Let's do... Okay. Let's first do, we have the 21 here. Let's multiply it. Wow. I guess we can get one ln by itself and then get the other one. Let's start out with by getting this one by itself. Multiply this by 21. Okay, so then we have 3 plus ln of x equals, here we got 5 times 21, 105 ln. Now, this is definitely not going to go to 42. Then we do minus 3. We get ln of x equals 102 ln. Oh, wait, no. Since that's multiplied, sorry, that's 105 ln minus 3. And then I guess we need to divide ln. Jeez. Divide ln. That would make these cancel out, so you get x equals 105 minus 3, which is 102. That's not a valid thing, so sorry. That's not the kind of question you would see. I think you don't usually have an ln on both sides, so let's pretend that that's only a 5. Sorry with so many errors on here. That I know it's not like that for the exponential. Oops. Why is that 21 racing? Right, still, the answer wouldn't be 42. Okay, so no ln. Bye-bye. Pretend like that's not there. Alright, still, we're going to multiply by 21. And we get 3 of ln x equals 105. We then subtract by 3 on both sides. Ln of x equals 102. Now we need to multiply by e, both sides, and our power rule says that 102 times e is also e to the 102. So let's change that. And these cancel, so we have x equals e to the 102. And remember, e is actually a value, so we can type that into the calculator. E to the 102. Oh, let's just leave it as e to the 102, because it has something with 42 or 44 decimals or something. Or, yeah, let's just leave it as that. So that is our logarithm problem. So sorry for errors on 3, 5, and 6. I should have been more careful when I made that. Hopefully it makes sense, though. Exponential. All right, when we're solving exponential equations, we need to make bases alike. Now, I said, and let me actually, I can see, solving for x. Yeah, it was the last lesson of Unit 6 that I did. I said that there was no mathematical way to find something when there's something like this. X to what power equals y? But there is, and that is the logarithm. I just didn't say because that's not what unit we were on yet. Now we can actually see this formally. Okay. We need to make the bases alike by just personal knowledge, or, if you really want to get technical, the log B log A rule. Then the bases are able to cancel out, and then you solve as normal. If there is an e, you multiply both sides by ln to cancel out the e. Alright, examples. This one, we need to make the bases alike. And when we're doing that, we have to do logarithm of the second one that you see, 4. Well, preferably the larger one, actually. And then divide by log of 2. And we should get 2. Log of 4 divided by log of 2 equals 2. What is log of 2? Not 2. but so that's not how it works. It doesn't change to that, but it gets the value is 2 when you get that. But like I said, you could do your own knowledge, because you could know that 2 squared equals 4, 2 to power. So what we were really finding just now is 2 to what power equals 4. We made the 4 on the top, the 2 on the bottom, and we found out that it was 2. But we know that, hopefully. But in case you didn't, that's how you do it mathematically. And we'll see with the 771 that will be useful. Okay, so now we know that we need to do 2 to the second power, and then that, and we need to make that multiplied by that. But now that these are the same, we cancel them out. Well, this would be for the whole thing, but and now we just have 2 to or times x plus 3 equals, this really had a power of 1, so 2x minus 6 equals 1, 2x equals 7, x equals 7 over 2. Got the right answer. Good. Alright, now for this one, we need to make the bases alike. Obviously we don't know, we're trying to find out 7 to what power equals 71. 71 and 7 aren't perfect squares, so that's kind of hard. That's why we need to use our logarithm BA rule. So we need to do logarithm of 71 on the top, logarithm of 7 on the bottom. So logarithm of 71 divided by logarithm of 7 equals approximately 2.2. So we can say 7 to the approximately 2.2 power equals 71. Let's see. You get 72, so it's almost there. Okay, so now we have this 2.2, and then we need to multiply that by the x plus 2 equals 71 to the power of 1. Cancel out the bases now that they're alike. And 2.2, we have 2.2x plus 4.4 equals 1. Then we have 2.2x equals negative 3.4. And negative 3.4 divided by 2.2 is negative 1.54 repeating, both 5 and 4 repeating. And on my calculator, I'm doing math, fraction, and in fraction form, that is negative 17 over 11, which is the answer. Okay, now we have one more problem. All right, here we have an e, and remember what we said? We need to multiply both sides by the ln. Well, actually, you need to isolate the e first. Let's isolate the e by dividing by 7. E of 4x equals 5. Now multiply by ln on both sides. Oops. Okay. These cancel out, so we have 4x equals ln of 5. Then you divide by 4, and we get ln of 5 divided by 4 is not what it says the answer is. I got 0.4 approximately. But let's plug it in to the calculator to see if old me is right or new me is right. Okay, so is 7 times e to the power of 4 times 0.4 35? Yes, it is. So I must have done something wrong with the answer. So we did get it right. Okay, so that will be it for this video. That's all the lessons for this unit. It was kind of a little bit strange because this is new with the logs and ln's and stuff. But hopefully it helped, and I might do a test review video. But so I said that this was going to be the last unit. But it's actually not. I'm going to do 2 more units. Either 1 or 2, probably 2, on conics and circle. So, that's it for this video, and I might do a review, might not. Obviously, if there's no video left in this playlist, I guess I didn't do it. But there might be, so thanks for watching, that'll be it.